Hello, ladies and gentlemen. Root Beer here. We're going to be wrapping up our 2018 Hypatia in this video. That's right, it's time for question number 4. So let's dive in and take a look. So we've got two parts for question number 4. There's an A part and a B part. What have we got for A? Consider the two parabolas defined by the equations x squared minus 8x plus 17 and negative x squared, this is a downward facing parabola, plus 4x plus 7. We got two things to do in this question. Determine the coordinates of the vertices of the two parabolas. Okay, that won't be too hard. We actually know the equations. Just complete the square and get it in vertex form. And 2, suppose that these two parabolas intersect at the points P and Q. Explain why quadrilateral V1, P, V2, where the V's are the vertices, Q is a parallelogram. It's a parallelogram. And just a quick glance down at B, looks like we've got other parabolas. Two parabolas, this time, again, a downward-facing one, negative x squared plus bx plus c. And then a very simple one, just the standard parabola, y equals x squared. And we've got vertices v3 and v4. For some values, B and C, these parabolas will intersect. I guess the other one sort of looks like this. Determine all pairs BC for which points R and S exist and all 4 points are distinct. Because it is possible that the vertex of one of the parabolas is on here. So we do want to make sure they're distinct, I guess. And then the second part of this one, really this should have been broken down into an A, B, C, and D maybe, but oh well. Determine all pairs BC for which the points R and S exist. All the points are distinct. So we're just adding something on here. And the quadrilateral is a rectangle. So not just a parallelogram like up here, but we do want a full rectangle. Interesting. Rectangle, we really just need to show it's a parallelogram and has right angles. And right angles just mean negative reciprocal slopes, I guess. And we should be able to find, in terms of B and C, not only the vertex, but the intersection points. Alright, well, we'll let B sort of stew in the back of our minds for a little bit. We'll focus on A. A1, get the coordinates of the vertices. So we'll say put these parabolas in vertex form by completing the square. So we have y equals x squared, I think it was plus 8x plus 17. Minus 8x, my mistake. Okay, so minus. Okay, so half of negative 8 is negative 4. The square of that is 16. So we add 16, subtract 16, and that'll mostly cancel out with the 17. We'll get x minus 4 squared, and then minus 16 plus 17 is plus 1. So we've got 4 and 1 is the coordinate for one vertex. And then we've got negative x squared, I think it was plus 4x plus 7. Okay, good. So we'll do minus, and then x squared minus 4x plus 7. And so minus 4 divided by 2 is minus 2. Minus 2 squared is 4. So we add 4 and subtract 4. Bring the minus 4 out, but at the cost of a minus sign. So we get minus x squared minus 4x plus 4 inside, and then plus 4 plus 7. So this will be minus x minus 2 squared plus 11. So 2, 11 is our other vertex. And you might want to put a little highlighter or box around them. Or a therefore statement saying these are our two vertices. This is V1, this is V2. Okay. So, P and Q are the intersection points. Well, let's actually find P and Q, and then we'll be able to determine why it's a parallelogram. So a good way to test, incidentally, if you've got a parallelogram is to make sure that the opposite pairs of slopes are equal, because then the lines are parallel, right? So, let's get the intersection points. So find P and Q. So y is equal to y. X squared minus 8x plus 17 is minus x squared plus 4x plus 7. Let's get it all over onto one side. 2x squared minus 12x plus 10 is equal to 0. So x squared minus 6x plus 5 is equal to 0. This factors into minus 5 and minus 1. So we're going to have x equals 5, x equals 1. So we'll get 5, and then we plug in 5. Minus 5 squared is 25, minus 25. Plus 20 would be minus 5, plus 7 is 2. And then Q we'll say is at 1, and then minus 1 squared plus 4 is minus 1, plus 4 is 3, plus 7 is 10. There we go. Okay, so to check that they are parallel, or to check parallelogram, just check pairs of opposite slopes are equal. So what have we got for our points? We got 5, 2, 1, 10. We had 2, what was it? 2, 11, and 4, 1. Okay, so that's P, that's Q, that's V1, that's V2. So PV1, we can make a little chart actually. So PV1 needs to go with QV2, and then QV1, PV2, and we'll figure out their slope. I feel like I'm going to need a bit more space. Well, let's see how much the first one does. So 5 minus 2. Oops, that's the x coordinates. My mistake. Difference in y's over difference in x's. It's going to be 9 over 3, which is 3. QV2, this should also be 3 then. So difference in the y's over difference in the x's. 11 to 2. Oh, it should be 2 to 5. Add them swapped around. 10 and 1 over 1 and 4. That's also going to be 9 over negative 3. So that's negative 3. Those are the same. And now PV2 and QV1. Let's see, we'll have 2 minus 1 over 5 minus 4, which is a slope of 1. I will say 1 over 1, which is 1. And then QV1, so we'll do 10 minus 11 over 1 minus 2, negative 1 over negative 1, and that's also 1. They are the same. And so it's a parallelogram. Okay. Now, just thinking ahead to B2, I'm actually wondering if there's sort of a general rule that you get a parallelogram if the 4 points are distinct. Maybe not for general parabolas, but maybe for one upward-facing parabola and one downward-facing parabola, because obviously it wouldn't work for two upward-facing ones, I don't think. But an upward one and a downward one where maybe if the coefficient in front of the x, if the leading coefficient for the bottom one and the leading coefficient for the top one are negatives of each other. I feel like that might be a thing, that there are parabolas. And so I'm just trying to think ahead. Because we get a parabola with x squared and we get another one with negative x squared presented in both cases. And if we want to show a rectangle, we should show it's a parallelogram with angles of with right angles. And so the parallelogram thing might be kind of nice. We'll see if that comes up, but that's a guess I've got. Okay, so fresh sheet of paper, and now B. So we've got these two parabolas. Determine all pairs B, C for which R and S exist and the points are distinct. So first, let's say x squared plus bx plus c. And they are both pluses, right? We don't want to start this off the wrong way. So plus bx plus c. Okay, good. That's going to be x squared plus bx plus b over 2 squared minus b over 2 squared. And this is b squared over 4, but I want to write it out so that who's ever marking can follow what I'm doing. I'm just completing the square. So this will be x plus b over 2 all squared plus c minus b squared over 4. Right? Oh, I forgot the minus sign there. Alright, so this is all tweaked a little bit. I basically just need to redo the whole thing. So that pesky minus sign. So I was about to move forward with y equals x squared, whose vertex is pretty obvious, but then I realized I started both of them those with x squared, and didn't I just talk about x's and minus x's? So we'll do minus x squared minus bx. Then the same sort of thing, x squared minus bx plus b over 2 squared minus b over 2 squared. And that comes out again, but at the cost of a minus sign, so we'll get minus x squared minus bx plus b squared over 4 plus b squared over 4 plus c. Right? Minus minus cancels out, because we need to be very careful here so that the vertex form is done properly, because everything is going to build off of this. And I don't know, we'll say C first just because it's the smaller one, or the less fractiony one. So this has vertex b over 2 b squared over 4. Y equals x squared has vertex 0, 0. It's the origin. You don't really need to justify that one. If you want to, I suppose you really could do x minus 0 squared plus 0, but you're not getting any marks for that, so why waste your own time? Okay, so I've got the vertices here. That's nice and neat. And we can, I guess, figure out their intersections. So find R and S, and then we'll get formulas for all the 4 points we need, and just to make sure they're distinct, we'll make sure their x coordinates are all distinct or something like that. So y equals y. X squared is minus x squared plus bx plus c. So we'll say 2x squared minus bx minus c is equal to 0. Sort of have to use the quadratic formula because there's no good way to factor this. So negative b, which is just b because we already have a negative b, plus or minus square root b squared minus 4ac all over 2a. So this will be b plus or minus square root of b squared. The minuses will cancel out, and so we'll say plus 8c all over 4. Okay. That's not the nicest expression, but it's not terrible, I guess. So need R and S to be distinct. So b squared plus 8c has to be greater than 0. So that's a useful thing to know. Need 0, 0, and R and S to be distinct. This is... I don't like this form. This is what's annoying me. So maybe... if I draw a picture, I should have something like this, and then the other parabola comes around like this. So there's the one vertex, call it V3, and then there's our origin, we'll call that V4. Now, in order for R and S to be distinct, we do need solutions to the intersection, and that's fine. That's satisfied by this. So in order for R and S to be distinct from our vertices, well, R and S lie on both parabolas. We need the vertices to not be on both parabolas. So 0, 0 is not on y equals negative x squared plus bx plus c. So we need the y-coordinate 0 to not be minus 0 squared plus b times 0 plus c. So we need c to not be 0. As long as c isn't 0, then we don't pass through V4. At least for the downward facing parabola. And then for the upward facing parabola, we need V3, which was at b over 2 c plus b squared over 4. We need that to not be on y equals x squared. So we need c plus b squared over 4 to not be the same as b over 2 squared, which is b squared over 4. So once again, we just need c to not be 0. So c needs to not be 0, and b squared plus 8c needs to be greater than 0. That should be it. Because if v3 isn't on the red parabola, then it can't be the same as the origin. So those 2 points are therefore distinct. And if R was the same as the origin, then the origin would be on the blue parabola. If S was the same as V3, then V3 would be on the red parabola. And we've got that to not be true. So we need C to not be 0. And b squared plus 8c to be greater than 0. So, do they want... Now, then they don't tell me that b and c are integers in any way. They're saying determine all pairs b, c for which these points exist and are distinct. Is it enough just to leave it like that? Because obviously I can't list them all out. So is this the sort of conditions they're looking for? It's a little vague. Now obviously C can be negative a little bit. For example, if B were 3 and C were -1, this condition would be satisfied, and so would this one. And so we should be fine. Can we just quickly, off on the side, double check that? So we get -x² plus 3x minus 1. Although I'm not liking my choice of number there, but the parabola's vertex should be 3/2 and then -1 plus 9/4, which should be 5/4. And then, so that would be over by 1.5 and up by 1.25. So yeah, I agree that those would be distinct points. Okay. So, I don't know, I guess a little therefore statement. Any BC satisfying C not equal to 0 and B² plus 8C being greater than 0 will give R, S, V3, V4 as distinct points. Alright, I feel like there might be a cleaner way to say this. I'm not entirely sure, but I feel like there should be. Like, maybe just geometrically, we need the vertex of our other parabola to be up high enough that we can get two intersections. So I don't think we can just say, well, all the points down here won't work. So I think obviously if I do this, you'll get two intersection points there. No, okay, I'm going to leave it as is because we've got more question to do. There might be a cleaner way to write this. I suspect if there is, they would have it in their solutions. But I'm not about to stop what I'm doing to look their solutions up. If you got a nicer expression, then by all means leave it in the comments below. But I'm inclined to believe this suffices, and we'll use this for 2 most likely. Okay. So, determine all pairs BC for which the points R and S exist. The points are distinct, so that's fine. And V3R, V4S is a rectangle. Okay. So, well, we'll start off by saying, okay, by 1, we need C to not be 0 and B² plus 8C to be greater than 0. Okay? In order for the quadrilateral, this is the main focus, quadrilateral to be a rectangle, it must be a parallelogram, and we'll reiterate that that means opposite slopes are equal. And you just need one right angle at that point. So we could say something like R V4S have a right angle. Well, we could even say this. Let's say adjacent slopes That is, they share a common point. Be negative reciprocals. Okay, and we have expressions for all the points here. We got, well, we don't have expressions for all the points, right? We haven't figured out, we just got the x coordinates here for r and s, but it shouldn't be that bad because we just need to square it. So, we got 0, 0, b over 2, c plus b squared over 4. B plus or minus the square root of b squared plus 8c all over 4. Oops, it shouldn't be plus or minus. We'll say plus. And then whatever that is squared. We'll just leave it as that expression squared for a moment. So b minus square root of b squared plus 8c all over 4. And then b minus square root of b squared plus 8c all over 4 squared. So these are the points. Okay, so I think the first thing to do would be to do the negative reciprocals. I think that's going to be easiest. We'll do, so we'll call this one R, we'll call this one S. Actually, we'll switch that around and have this one be R and this one be S, just because I think with the minus sign, it seems like it should be further left, and therefore I was labeling the leftmost intersection point R in my earlier pictures. Called this one V4, V3, so the slope of SV4 is just going to be this value over this value because you're just subtracting 1. So b plus square root of b squared plus 8c all over 4. Slope of r v4 is just dividing by this amount. There we go. So these need to be negative reciprocals. Alright, so b plus square root of b squared plus 8c all over 4 needs to be negative 4 over b minus the square root of b squared plus 8c. Okay, cross multiply, you'll get difference of squares, so b squared minus b squared plus 8c. And then you'll get a minus 16 over here. So the b squareds will cancel out, and we'll be left with minus 8c is minus 16. C is going to be 2. Okay, so that narrows things down quite a bit. Okay, so C's got to be 2, and that means we're looking at, does it clear a whole lot up? I don't know. But it does mean we have one less variable to carry around. So the coordinates are now 0, 0, b over 2, 2 plus b squared over 4, b plus the square root of b squared plus 16 all over 4, and b plus the square root of b squared plus 16 all over 4 squared, and then b minus the square root of b squared plus 16 all over 4. and that very expression as well squared. Okay, so we've got two of the slopes. We just need to worry about the other two, s to v3 and r to v3. And these are the ones I've been dreading doing, but that's okay. Slope s to v3. I really hoped that more would pop out, specifically maybe some of the b's would eliminate, but it looks like they're going to have to be eliminated here. So 2 plus b squared over 4, and immediately, just so my order doesn't get messed up, I'll do b over 2 here. Minus b over 4 plus... Oh, I'm doing the... Yeah, this one's s, this one's r. Okay. Then square root b squared plus 16 all over 4. Minus... I don't like this over 4 keeps happening, but that's okay. And this needs to be equal to b plus the square root of b squared plus 16 all over 4. Otherwise, it's not a parallelogram. Okay, so b squared over 16 plus 2b square root of b squared plus 16 all over 16 plus b squared plus 16 all over 16. Okay, we can clean up 2, and that's a 1, so that goes away. We got a b squared over 16 and another b squared over 16, so that's b squared over 8. So that and that and that leave me with a b squared over 8. Alright, I think that's as good as I can get right now. Can we multiply? I'm thinking we're probably going to have to cross multiply in a moment. I'm trying to avoid that if I can. B over 2 minus b over 4 is going to leave me with a b over 4. And that'll change to a minus sign. That's going to be a minus sign. That goes away. Okay, so we got b squared over 8, b squared over, or b over 4. Yeah, definitely not. This 2 and this 16 can give me an 8 on the bottom, so that's something at least. Let's see here. So b squared over 8. I'm going to switch back to the black now. I'm done canceling things out. B squared minus b. I can take out a factor of b, can't I? B minus the square root of b squared plus 16 all over 8. And then on the bottom we have b minus the square root of b squared plus 16 all over 4. Well, that's going to cancel out with that. And then invert and multiply. We're going to be left with b over 2, I think, for this slope right here. So this slope is oops. So that slope's b over 2. That's kind of interesting. So that needs to be s v3. Okay, so b over 2 needs to be equal b plus square root of b squared plus 16 all over 4. So I'll get rid of the b over 4 on both sides. That leaves me with b over 4. Multiply through by 4. So b is the square root of b squared plus 16. So b squared is equal to b squared plus 16. 16 is equal to 0. Something has gone wrong. But what? So I've got the slopes that I want. And that is negative reciprocals, okay, so I'm not dissatisfied with that. I feel like I might have... Oh, I forgot one. Forgot this one, and that throws the whole thing off. Fantastic. Well, it doesn't throw the whole thing off, but I'm not pleased. But we can clean this up a little bit. Knew I'd forgotten something. There's no way 16 is equal to 0. Okay. And that cancellation was pretty messy. But we've got 1... I think I agree with everything else. So we've got 1 plus b, and then b minus the square root of b squared plus 16 all over 8 up here. I could change this to an 8 over 8. I don't think I will. I'm going to do this one over b minus b squared plus 16, because the cancellation really did work out nicely. And then this one over b minus square root of b squared plus 16 all over 4. Now this part still here becomes b over 2. And then we specifically chose... Yeah, this will turn out to be 4 over b minus the square root of b squared plus 16. But that's just going to be, thanks to our negative reciprocal here, it's just going to be negative of this thing, right? Okay, so this is going to be, and it's a plus this time, b plus the square root of b squared plus 8c all over 4, negative of that, sorry. So this needs to equal b plus the square root of b squared plus, I don't know why I said 8c there, it should be 16. Okay, so then b over 2 needs to be equal to 2 times b plus b squared plus 16 all over 4. Multiply by 2, the 4's will cancel out. So b needs to be equal to b plus b squared plus 16. The b's will cancel out, and so 0 needs to be equal to the square root of b squared plus 16. And we're not happy with that, because that means b squared plus 16 needs to be equal to 0, and that's impossible as well. Darn it. So, have I made more arithmetic mistakes? I'm happy with these slopes. Because if I were to do something like 3 plus the square root of 9 plus 16 all over 4, and that would be 3 plus 5 over 4, so that would be 2. And then negative 4 over 3 minus the square root of 9 plus 16 would be negative 4 over 3 minus 5, which would be negative 4 over negative 2, which is 2. So yeah, okay, these formulas do work. We're happy with that. I think it's probably just this cancellation. I have screwed the cancellation up somehow. So let's go through it, and we'll try and do it a little slower. Not a race, although we are on the last question, so we do want to be keeping an eye on the time. So 2 plus b squared over 4. Is there a better way to do this? Oh, wait a minute. This one doesn't need to be equal to b plus b squared plus 16. It needs to be equal to the one that's opposite it. B minus. Because that's RV4, R to the origin. Okay, so maybe the cancellation was right. We'll come back to that in a moment if this also turns out to be a problem. But maybe this will be a little nicer. Okay, so we've got b over 2 minus b over 4 minus the square root of b squared plus 16 over 4. Needs to be equal to b over 4 minus b squared plus 16 over 4. Those two cancel out to be b4, and so this is already happy. This is already satisfied. So do I really just need c equals 2? Because I think the next one's going to do the same sort of thing. So we need the slope of RV3. So that's again 2 plus, we'll do this one slowly. So it's b squared over 16 minus 2 times b times the square root of b squared plus 16. That's also over 16. Plus b squared plus 16 all over 16. One thing we're going to do right away, that's going to turn into an over 8. That's going to turn into a 1. So we will get rid of that 2 and that 1 and turn this into a 1. Okay. Oh, this is b squared over 4, silly me. Okay, so these two added together will become a b squared over 8. B squared over 4 minus b squared over 8 is plus b squared over 8. And then we'll have minus minus, so plus b square root b squared plus 16 all over 8. Then that's over b over 2 minus b minus square root of b squared plus 16 all over 4. No squareds there. So we'll split this up to b over 4 minus this over 4. So b over 2 minus b over 4 will be b over 4. Minus minus, it'll be plus square root of b squared plus 16 over 4. Okay. So that'll turn into 1 over, it'll turn into 4 over b plus the square root of b squared plus 16 plus b over 2 again. Because group these two together, the 8 divided by 4 leaves a 2 on the bottom. take out a factor of b, and that's happy. Again, this is negative reciprocal. So the choice is C. This is a negative reciprocal. So we check the RV3 is equal to, it's slopes, by the way. Slope SV4, and that one was B plus the square root of B squared plus 16 all over 4. And this is B over 2 minus B minus square root of B squared plus 16 all over 4, right? And so this is B over 4, and this is plus square root of B squared plus 16 over 4. This is B over 2 minus B over 4 plus square root of B squared plus 16 over 4. Cancels, 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 cancels. So we just need C to not be 0, B squared plus 8C to be greater than 0, and we need C to be equal to 2. So that's satisfied. Then this would be B squared plus 16 is greater than 0, but of course B squared is a perfect square, so it's greater than or equal to 0, so B squared plus 16 is greater than or equal to 16, which is greater than 0. So any pair BC with, any B will do really, with C equal to 2 will give a rectangle. Okay. So other than messing up the calculation of the slope once, and then choosing the wrong slope back here, I would say that went fairly smoothly. And this is a much, much better final answer than our final answer to 1, but I'd say they're still pretty good and they still give us everything. But again, if you have a cleaner expression for B1, please leave it in the comments below because I would love to see it. But other than that, that finishes off the Hypatia. So nothing else to say. If you're looking for more Hypatia contests, feel free to poke around the channel. And other than that, have yourself a wonderful day.